So how do we select controls? Well, the first thing is to know what's the problem. Understanding the risk. Understanding the risk means we know what needs to be protected, we understand the threats and vulnerabilities, and we develop policies. Policies set out that standard that we are to reach to. Policies set out this is management's commitment to attaining this goal. And a policy provides that authority for us to put in an effective control framework. We need to know what needs protection, which systems are especially sensitive or critical, and what data we have is either sensitive or critical. When we've identified that, we can classify it so that those systems and data will receive the appropriate level of protection. We also want to harden external systems. Anything that's facing the internet. The internet is something which is untrusted. And therefore, whenever we have something which is the gateway or that interface to an untrusted area, we will harden those devices, something we'll call a bastion host, for example. And a hardened system is a system where we turn off all of the functionality, all of the services, all of the ports that are not necessary. You can think of hardening an external system similar to building then a tower or building a wall around a city. The idea of hardening is that we provide that hard outer boundary with a limited number of gates, very few services provided through that wall. And by doing that, we reduce then the attack surface. We make it that much more difficult for an attacker to be able to launch a successful attack. Security must become, of course, real. And this is where we need security procedures. A moment ago, we discussed security policy, and policy is important. But in the end, policy is nothing but words. Policy needs to be backed up by actions. And this is where security procedures are those actions then that implement the objective of policy. For example, a change control procedure. A procedure that tries to ensure that only tested, documented, and authorized changes are made to a system. Trying to prevent unauthorized change. Trying to control change so it has had proper approvals and proper review. We know that a time of change is a time of risk. Quite often it's through the changes that we implement that we actually then introduce new vulnerabilities. And a proper change control process can help then to mitigate that risk. Security is everybody's job. And everyone has to know that. Everyone has to understand the risks and certainly their obligations to follow policies and procedures. Awareness training should be provided to all staff. Take, for example, spam. So everyone knows how to recognize spam, how to make sure they don't click on that link or open that attachment. Everybody in the organization should be familiar with social engineering so they don't become a victim of intimidation or name dropping and these various types of social engineering used so effectively then by many criminals. We also put in, of course, technical controls. We can put in a firewall, and we're going to look at firewalls in a lot more detail in just a few moments. We can also put in intrusion detection and intrusion prevention systems. These are incredibly effective and valuable tools. However, the reason this is listed here is because a firewall or an IDS in itself is only a tool, like a hammer that sits on a workbench. And it's really of no value unless we use that tool properly. And to use that tool properly, we need procedures. procedures for how it is to be implemented, maintained, monitored, how to make sure that the staff that is using that tool, that firewall, is able to use that firewall effectively. Of course, our primary goal is to try to prevent problems, but we know that doesn't always work. Things are still going to go wrong. And this is where we need an incident handling procedure. We need a procedure that will help us to be able to detect and respond effectively to any type of an incident that happens. And in incident handling, of course, we want to then reduce the impact of that incident and get back to normal as quickly as possible. We also put in procedures and policies that say things like all email must be encrypted. All of our data which is being sent off-site, maybe to a branch office, should be encrypted. Our backups should be encrypted. And these procedures help us then to ensure that we have protected our data even when it's in a vulnerable location. We also saw a moment ago when we discussed effective security controls, the problem that in many cases there are controls, but they're just not working. So this is where we as auditors play a key role. We monitor to make sure those controls are actually effective. Are they accomplishing what that control should be doing? It's not good enough if we have a control that's not actually working correctly. One of the tools we use frequently, especially in the outside perimeter of our networks, are firewalls. However, as we'll look at in just a moment, firewalls can also be used inside the organization as well. A firewall is simply defined as a device that controls traffic flowing from one network to another. A firewall is a gateway. It's a device that sits there between two networks and has then a set of rules that controls what traffic which should be flowing from one side to the other side and vice versa. And this is a point that we should always remember, is that a good firewall does not just protect me from being attacked, but it also checks to make sure that I'm not the source of an attack on somebody else. A good firewall makes sure, through maybe things like data loss and data leakage prevention, that I don't have sensitive data going out of my network either. Now, we use firewalls primarily on the outside to protect our DMZs and so on from then the internet. However, we also use them internally between different network segments. Maybe we have an area of research or an area like HR where very few people should actually have access to that part of the network. And we can put in firewalls that enforce rules where traffic can flow and where people can go inside the organization. The same as we do with our buildings. You have external doors that protect us from then the outside. We also have internal doors on certain offices as well. Now, the basic rule for firewall quite often is that deny everything unless it's explicitly allowed. Now, that's a very restrictive rule. That's not to say that's what we should always do. But in many cases, the idea of a firewall is that it is going to try to very much restrict access to that which we know can be trusted. And anything which we are not familiar with then could be then denied or restricted. So where do we use these? Well, we use them to block access to sites on the internet. We can block traffic so people can't go to a site we don't want them to go to. We can then, of course, block traffic that comes in from the internet. Limit the types of traffic that'll come into the organization's network. Maybe I'll only allow, for example, certain types of traffic, and other traffic quite simply would just be dropped. Maybe my firewall is open on port 80. It'll allow HTTP traffic, but my firewall might be locked on port 25, on port 53, and some of these other ports used for mail, DNS, and other things where we quite simply say no, that we don't want traffic to come into our network through those doors, shall we say. Now, the other advantage of a firewall is it allows us to keep a record of what traffic has gone through our network. It can monitor and record the traffic. This will allow us then to go back and investigate if we've had any type of a problem. We also use firewalls quite often as the endpoints for an encrypted tunnel. If I'm going to set up traffic between two different networks, I can encrypt that data, for example, using a virtual private network. And the firewall itself becomes those endpoints, where then the traffic that's going out gets encrypted at the firewall and decrypted at the far end. This is often done with, for example, a IPsec VPN. Now, there are many different types of firewalls, just like there are many different types of cars. The most simple and basic firewall is one that's called a packet filtering firewall, quite often just a router. And packet filtering is very simply where it's sort of like what a mailroom clerk does perhaps in your office, or you do when you get home. You pick up the mail comes in, and some of the mail you would just immediately throw away. You don't even open it. You see, for example, it's advertising or something you really don't care about, you just drop it immediately. That's a type of traffic you just don't want. And that's a simple packet filtering. Now, obviously, a packet filtering is a very basic level of control because it is not really looked inside to see what's inside the packet. And for that, we'll need a more advanced firewall, for example, an application firewall or a stateful inspection firewall. We also sometimes will use firewalls as a proxy or an intermediary between two different, should we say, entities. We have our trusted internal entity, we then have outside an external entity, and in order to protect the trusted internal entity, we then put in place a proxy that says, I'll go get that information for you. It allows us to filter that before it passes it then on to the inside. Many of our firewalls have the ability to do deep packet inspection, getting right in and looking at the actual data itself to see whether or not there's something within the data coming into our organization which would violate policies. These are often called then next generation firewalls. So a packet filtering firewall is the simplest. It quite simply is going to be ineffective against a more advanced attack, and it's not going to be able to see things if they're, should we say, encrypted. It's sort of like, again, the mailroom. If it's only making its decision based on the outside of the envelope, the from address and the to address, it's not going to be able to see what's then tunneled or carried inside of that envelope. It reads the network traffic headers, and it has an access control list that says block all traffic from these locations, or block all these types of traffic, or don't allow traffic to this location. And those rules quite simply say what should or should not be allowed through the firewall. We can block ports, doorways, and we can of course limit certain types of protocols. You could, for example, set up in your firewall a simple little rule that says don't allow a ping. Somebody sends a ping packet, you just sort of say, no, we're not even going to respond to that. We'll just drop it and let it time out. We won't allow ICMP traffic. And of course, quite often it's based on addresses. We will block known bad addresses or obviously spoofed addresses and so on. There are many, of course, problems that lead to internet-based attacks. The fact is that quite often when a person is going to launch an attack, they hide their address. They do IP spoofing. So the traffic might look like it came from a legitimate or an unknown site rather than from a known bad site. And IP spoofing is very easy to do in the internet and has led to, of course, many problems as a result. There's been also a number of attacks, especially at the IP level, related to then the fragmentation and reassembly of packets. A fragmentation attack, such as an overlapping fragment, tiny fragment, teardrop attacks, All of these take advantages of weaknesses within Internet protocol. And fragmentation attacks then, of course, can be used in order to then defeat or circumvent some of those firewall rules that should have helped protect me. Sometimes we'll manipulate the route that traffic takes. This is what we can call source routing. And source routing will allow, in some cases, a person to then route traffic through an insecure location where it could, say, be monitored or altered. And the other problem is that many things which are actually malicious will run over another service that is known good. For example, they'll take something which is malicious and tunnel that over a service that we would normally think, oh, that's okay. So this is part of the problem, is the ingenuity and inventiveness of the attackers. An application firewall is the most, should we say, in-depth and really the most effective type of firewall we have. Because this is not just making decisions at layer 3 of the OSI stack, sort of the network layer, but rather it's making decisions based at the application layer. It's making decisions by looking at the actual data, the payload within the packet. And we have two main types here of application firewalls that operate quite often as a proxy. An application level proxy is one that will, say, for example, protect all HTTP traffic. And it'll take a look at any traffic that comes in, examine to see if there's anything strange or unwelcome within that packet. A circuit level proxy is one that operates a little bit more at, say, the session layer instead of the application layer. And it also acts as an intermediary. An example of a circuit level proxy was SOCS, which stood for Socket Security. And a SOC server said that when an internal employee is going to go out onto the internet, it says, oh, I'll get that for you. And it would go out, retrieve the information the employee had asked for. When it brought it back, it would then check and examine it to make sure it was trustworthy before it would pass it then on to that internal employee. And a circuit level proxy could handle many different types of traffic, where quite often an application level is maybe limited to, say, one specific type of protocol. And this, of course, is what we could see with an HTTP proxy, often used as a web application firewall. We mentioned that anytime we put something out at the perimeter of our network, we want to harden it. And an example of this is a bastion. A bastion host is a hardened, fortified device that's used on an internet-facing system. For example, we might have a web application. That web application should operate on a server which is configured as a bastion. It's hardened. We've turned off all unnecessary ports, protocols, services. We've reduced the attack surface so there's very few doorways or windows into this server. We've removed the administrative interfaces, because by doing this, we make it that much more difficult for a person to be able to attack that server. So the bastion, by its very nature, is something like a tower defending an old medieval city, with a minimal level of functionality available at it. Quite often, the bastion then is used to host those services that we're providing out onto the internet, such as our web application. By closing off all unnecessary ports, protocols, and services, we can then minimize the attack surface. Minimizing the attack surface will make it that much more difficult for the attacker to find a way in and then cause damage. One of the common firewalls we use, an expensive but a very effective firewall, is one that's called stateful inspection. We use the term state a lot within the information security world. State can be defined as the condition an entity is in at a point in time. For example, you could be tired. You could be hungry. You could be excited. But the point is, that state that you're in can change. In the protection of information assets world, we do the same thing. We look for what state is a communication in. Is it already a trusted connection, or is this an unknown state? Something that comes into us, for example, from the internet, we might look at it and say, do I want to allow this? Is this something that I know about? And so what a stateful inspection firewall will do is it'll take, for example, a request that went from an internal user that went out onto the internet and says, I need this information. And the stateful inspection firewall will log that. It'll track that outgoing request. So now when a reply comes back, it checks its log and says, oh, yes, that internal user asked for that information, so therefore that is a legitimate request and will allow it to go through. But if something comes in, say for example some UDP traffic comes in that's unsolicited, and it says nobody asked for this, so since nobody asked for it, it's not welcome. And so what a stateful inspection will do, will drop something like unsolicited UDP traffic. The other thing that does then is it prevents then a connection to be made to the internal network that actually originated from outside. No, it says, if we want a connection, we will establish that connection. We won't allow a connection that came in from an outside source. The next generation firewalls have the ability, though it's not always used, to actually in many cases operate as a man in the middle. A next generation firewall takes the traffic going out of my internal network, will examine it in detail before it allows it to go out. And even if that traffic is encrypted, sometimes a next generation firewall will then be able to decrypt that or will block it if it doesn't have the correct keys to do the decryption. If a person from inside tries to establish an encrypted connection to outside, it will often the firewall will establish that encrypted connection and then create a separate encryption to the internal employee. That allows the firewall to decrypt and examine the traffic before it's then passed on. Now, we can understand that this is going to cause a performance hit. And so many organizations that even use next generation firewalls don't actually use that capability. That's also, of course, comes down to privacy and trust issues as well. What they will do then is they will establish those secure encrypted connections on behalf of the internal user. We have another type of firewall known as a kernel proxy. And this is one that specifically protects the core of our system. The core of our system, called the kernel, of course manages all the operation and all the security of our system. And a kernel proxy turns around and says, no, we will not allow any changes to that security kernel without making sure that those are certainly approved by the administrator. When an organization has been subject to SYN flood attacks, then we see the use of things like a SYN proxy or even companies that operate now as a point where a flood of traffic coming in with a synchronization request denial of service gets diverted off out of the way or deflected. And so that instead of that traffic being able to actually then affect our internal system and flood our network, it gets shunted off to the side so that we're still able to continue service.